Hi everyone, my name is Praveen. I'm a software engineer at Microsoft. I work in the SwiftKey team based in London. I've been at the company for about 3 years now. During my time here, my focus has been on, uh, sorry, yeah. During my time here, my focus has been on things like making SwiftKey lighter and performant. I worked on 3D rendering for one of the features we released recently, and more recently, the navigation component, and also migrating our CI/CD infrastructure to Azure DevOps. So before we dive in, I just wanted to give a quick introduction about what SwiftKey, sort of promote my team and the culture. So for those of you who don't know SwiftKey, here is a not so small video about SwiftKey. All right, that's about SwiftKey. Let's dive into the topics. Um, so today here to talk about Android navigation. So what's navigation, and this is what Google official docs has to say about it. Um, keeps going forward. Sorry, one second. Yeah, navigation. This is what Google Docs has to say about navigation. So navigation refers to the interactions that users perform, different actions that users perform on your apps to navigate across different pieces of content within your application. Obviously, different platforms have different guidelines on how navigation works compared to Android versus iOS versus Windows. This is to keep a consistent behavior across different applications for the user, so that users come to expect with certain expectations on how apps should work, how the fundamental things like navigation should work. So Android has its own principles of navigation. So let's start with the first one. There's actually 5 principles of navigation. Starting the first one is fixed start destination, which means your application should always have a fixed start destination. So when the user taps on the icon of your app, the home screen that they see should always be fixed, not something different each time. Obviously, there are exceptions to this, such as things like one-time setup and login screens are not considered as start destinations because they're conditional. So you can exclude those things from your, you can consider not those things as not necessarily start destinations. And the second one is navigation state. The state of your navigation is represented as a stack. What it means is the last thing that goes in the stack is the first thing that comes out of the stack. So when users navigate across your app, you basically build up a stack where you take up from the top of the stack when the user presses the back button. This is what most people already do. And the next one is the up and back button. It keeps going forward automatically. I'm not sure why. So the up and back button, which is the up button, is the one you see on the top left corner of your application, and the back button is the button is the back button you see in the navigation bar. Or with the latest APIs of Android, it's the back gesture navigation. They should have identical behavior. And the fourth one goes in hand with the third one, which is up button never exits your app. So essentially, you would have to not show the up arrow in your action bar when you're already on the home screen, so that it complies with the third and the fourth rules together. And last but not least is deep link. Deep linking should simulate manual navigation. This is probably the one that's violated the most. So what I mean is, let's say you have an application where user goes from launches the application. Let's say you have a garden application where user launches the application, they see a list of plants in your garden, and then when they select a plant, they go to the plant details, right? So far so good. Now let's say you have a deep link that launches into the details of a specific plant. So when they do this, you could have a backstack that looks like this, or you could have a backstack that looks like this. Is a stack A, which is you have the browser at the back of the backstack, and top of it is the plant details, or the stack B, which is browser and then the home screen of your application where you list out all the plants and the details of a specific plant. So you could have either stack A or stack B. I've asked the organizers to create a poll to see which navigation backstack does different applications follow. So the poll should be out soon. We don't need the answers to the poll right away, but it's good to look at what different developers' applications are doing, which backstack do they actually follow, to see how many of us really follow this guideline or not. Because these are all essentially guidelines. No one is enforcing you to do this, but it gives a very consistent user experience. So according to the principle, one is correct, one is not. So it's the stack B. Now, the vanilla implementation of Android is so you have different screens, right? And these screens can be activities, which you can navigate using start activity flag, or it could be fragments, which you can navigate using fragment manager and fragment manager transactions. This is the vanilla implementation, which would work for most of us. For most common scenarios, we could just use this and be done with it. But however, when you pile more things on top of it, such as navigation UI elements, let's say you have a bottom navigation bar in your application, and then you can add the default behavior, something like this. Depending on which element is selected in the bottom navigation bar, you can open the appropriate fragment. And that would work. So when the user taps on dashboard, it would go to dashboard. And when the user taps on notifications, it would go to notifications. So far, so good. But what happens when the user taps on home screen? So your backstack looks something like this. So this is problematic because when the user presses back button from the home screen, the user would probably expect to leave the application, but not go through something like this to the notifications and then dashboard and then again home screen before they actually exit the application. Obviously, we already know how to work around these things by using flags when we're doing the fragment transactions. However, that's not everything. We can also run into other issues such as this. You see, when you press the back button, we also have to make sure the right UI element is highlighted based on which destination or which screen are the users currently seeing. So we know how to handle all these things. What I'm trying to point out is that these are not trivial. They don't just come out of the box. This is something we have to handle manually, depending on which UI elements are we using, right? Now, if you go one step further and take scenarios like deep linking, it can be really hard because when you have a deep link that goes from screen 1, 2, 3, when users navigate in your application, you would probably have a backstack, something like this. This is what we had for most of our deep links. We would go from browser straight to the deep link. However, if you remember the principles we just discussed about, it should be having a backstack, something like this. And this would be much harder to implement because your navigation, the code for navigating to this logic would be spread across multiple destinations, and it's not very scalable as you add more and more destinations, because you pollute basically a lot of those classes to had to do with your deep linking logic is spread across multiple classes, which kind of messes up the maintenance of this logic. And to get an overview of what's happening, right? So lots of issues I've discussed here. So the Google understood all these issues, so they came up with the Android X navigation component. It's not a single library; it's rather a collection of libraries that handles navigation for us. It handles things like, well, navigation, and but in a more navigation compliant way with the principles of Android navigation. And it also supports UI components like the bottom navigation, or the side, or the sidebar, or other UI navigation elements. And it also supports things like type-safe arguments, view models, and animations. There's a lot of other features that I haven't mentioned here to avoid spoilers, but we'll see them very soon. So let's start with the basics, right? So at the heart of the navigation component is the navigation graph, which looks something like this. So the navigation graph has two, so you have the destinations, which are different screens that users can navigate in your application, like the home screen, the dashboard, notifications, etc. And then you have the links that connect them. These are called actions. So actions are the paths that users can take when they navigate between your destinations. So you want to navigate from home to dashboard, you take one of those paths. These are called actions in the navigation component terminology, let's say. The next one is the navigation editor. This is not necessarily part of the navigation component suite of libraries, but this is an IDE tool that comes with Android Studio that allows you to use the navigation component in a more friendly way. So the navigation graph I showed you would look something like this in the Android Studio's navigation editor. So on the left, you have the destination panels, where it lists all the screens of your application, or all the screens that are part of this navigation graph, including the host screen, which we'll see in a minute. And then you have the visual representation of your graph. Your navigation graph is an XML resource, like most other Android resources, but this is a visual representation of the same. Or you could have attributes. So attributes panel shows all the attributes of a selected component within the UI. So if you select a screen, it will show you all the actions, deep links, and arguments. And if you select an action, it will show the attributes of the action, right? Now, so we talked about what are destinations, and destinations could be anything. It could be fragments, activities, dialogues, or even custom views, right? So how do we define them? Something like this. So this is the basic navigation graph. This is what a very basic navigation graph looks like. So you have the navigation graph tags, and inside the navigation graph, you define your destinations. This is an example where I'm showing you a fragment destination where it points to the Java class or the Kotlin class of the fragment, and then a label, which we'll see more in details what we use these things for. So this is a very basic example of a destination. And then we have different screens in our application represented as destinations. And then we have actions. So actions are the paths that users can take to navigate from one destination to another. This is a fundamental thing that any application supports, right? So this is how you define actions. So the interesting thing about action is it's not on its own. So an action starts from one destination, goes to another destination. So for this reason, an action generally has a fixed source and a fixed destination. So you define an action within the source. So for all the paths that you can take out of the home screen, you define them as actions, and each action will point to a destination. So you define actions as part of the destination where they originate from. So let's say call it as part of the screen where they originate from. And the next part of all this, now we know how to navigate our destinations and actions. So next item in the list is the navigation host. So this is the empty container in which destinations come in and out of. So this is like a placeholder where we can put different destinations and show them as a whole uh, part of our application. So you would look something like this. It's your standard activity layout. So you have a constraint layout and a toolbar at the top and a bottom navigation at the bottom, at the down, and you have a fragment view where the only difference here from a typical fragment is the name here. So this points out to a host implementation. A host implementation knows how to swap in and out different hosts, different destinations. So this is a Android navigation component comes with a default implementation called the nav host fragment, which is what we'll use for almost any scenario we could think of. It's very rare that we want to implement our own, but the default one would work for most scenarios. And then you have an extra tag called the navigation graph. So when you declare these two tags and run your application will start not with an empty screen, but rather the first screen within your navigation graph. So every navigation graph has a start destination. So when you run the application with these changes we discussed, you will have the first destination of your graph shown here, and that's about right. You would have finished your first screen, but it was never about showing just the first screen, right? So it's about how do we navigate, and how do we navigate in a more efficient and easy to maintain way, right? So going back to navigation, the heart of navigation, actually navigating to different destinations, is the Nav controller. So the Nav controller, it manages navigation within a given host. Each host has its own Nav controller. So if you have different hosts, they have their own Nav controllers. And how do you get access to the Nav controller? We have Kotlin extension functions for activity, fragment, and view. You can use activity.find nav controller with a view, which is part of the navigation graph, or you can just call it directly within a fragment, which is part of the navigation graph. Or more likely, you would use it view.find nav controller in the context of a view, because we don't just navigate out of the blue. We navigate when user performs an action on a view. So I find the last one is the one we'll most likely use anyway. So once we have a nav controller, let's go to actually navigating to destinations, right? So you have multiple ways you can navigate to your destinations. The common one is using the action ID. So when you define your actions, you declare an ID for each of these actions. And once you have some actions declared in your destination, you can use find nav controller dot navigate. You can do it on click or on swipe. You get to decide when you call this navigate, but when you do this, it will navigate to the destination declared by this action. Right? This is good. And I talked about deep links. Sorry. Deep links. So each destination can also have a deep link, which is a URL that you decide for each destination. So you can also use deep links to navigate to a destination if you prefer. And last but not least is a type safe way, which is what I would recommend to do. So a type safe, because IDs can be anything. IDs cannot necessarily point to an action. It can point to a view. It can point to a resource or an image file, right? So the type safe way of using navigation gives you some compile time guarantees that you're using the right element when you're using the navigation. So you can get all the directions that you can take from the home fragment and then decide which action. So it gives you autocomplete and some guarantees at compile time when you're navigating. So those are three ways you can navigate to destinations. Right. Now, that's about the basics, and that's not everything. So we need more. We need more than just navigation. Navigation is not just about this. It's more than that. And the first thing that comes to mind is passing data between destinations. So the navigation graph, the navigation component has arguments. So it has a concept of arguments. So arguments can be part of either the destination or they can be part of the action. So this is how you define arguments within your destination. Within a destination, you can define an argument tag and you give it a name and the type of the argument. And every time you want to navigate, this argument has to be passed because it's part of the destination. The destination needs an argument if you want to navigate to it. It can also be part of the action, but this is how you navigate this is how you navigate. You have the same types of action, and then you use the value of the argument. Now, you can't use the action without passing in the argument. So this is an advantage of using the types of navigation because it enforces you to pass the expected arguments when you're navigating to a destination. So, and the next one is animations. So we don't want to just navigate out of the blue. So animations are one very common feature of our applications. So the Android navigation component does support animations when you're navigating across destinations. The action which declares the navigation has properties for different animations that we can do as part of this change. It also supports shared element transitions if it's something you do. I'm not sure why it keeps going forward. It's kind of ruining my surprises. Oh well. So the real world applications are not that simple. They usually have a much bigger navigation graph. Once you start importing your application, different screens in your app into your navigation graph, you'll see that your graph gets really, really big. This is a very simple. This one looks big, but this is even a simpler navigation graph than what we might see in a real world application. So as the graph gets bigger and bigger, it becomes harder to manage or harder to even view it in a single graph. So navigation component supports nested graphs. So you can do, for instance, you can group a subset of your destinations or a subgraph of your whole navigation graph into a nested graph, and then destinations. So the downside of this is when you group them into a subgraph, the destinations outside the subgraph won't be able to refer to any random destination within the subgraph. They have to refer to the start destination. So if you did a right grouping, you wouldn't need to refer to any random destination within the subgraph. So how do we do this? Well, one way to do this is just put the destination. So you group all the destinations which you want to group, and put declare another navigation graph within your original navigation graph. You have the same file. You just group them into you can group them by just putting it under the navigation tag. So this would look something like this in the navigation editor. So you'll have the root graph, and then you can select the subgraph, and then you'll see the subgraph. So this is really nice when you want to navigate, when you want to manage a big complex application. This does have its downsides. So I would prefer something like this, where you can move this subgraph into a new file and then include that in your root navigation. The advantages of this is when developers are working on different parts of your application, you wouldn't want them all to work on a single file. Then you would have to deal with Git clashes and lots of other issues when multiple people are working on the same file, right? Another advantage of using an external file for your subgraphs is you can include graphs from other modules and libraries. So it really goes a long way when you're wanting to modularize your application or different parts of your application into a module or a library. So one issue we talked about that we agreed that it's harder to do for the vanilla implementation is deep linking. And this is a breeze with the navigation component. When we talk about deep links, there's actually two types of deep links. So we have explicit deep linking, and then we have implicit deep linking. We'll go into each of these and how to do it with the navigation component. So explicit deep linking is when we use a pending intent to launch the destination. So this is the deep linking that we use when launching a destination in your app from a notification bar or a widget. So any place where you want to use a pending intent is where you would be using explicit deep linking. And the navigation component has a tool to build pending intents using the nav deep link builder. So you can set the graph, and then you can set the destination within the graph, and then pass in the arguments you want to pass to the destination when it's launched. And then you can create a pending intent. And when the pending intent is used, it will take the user to the right destination with the required arguments that needs to be passed. The behavior the user sees is when they launch an explicit deep link, they'll see a task. The task pack is clear, so they don't see every destination that leads up to the destination, every screen that leads up to the destination of the deep link, but rather they'll just see the source screen and then the destination screen. So this is a quirk of the navigation component. Now, implicit deep links are the ones we typically use in Play Store listings or referrals or websites, where you have a URL for a specific destination in your app, and then when the user follows these URLs, give the option to open this the specific screen within your app, right? So you can do something like this. So within a destination, we have the deep link property, which tells which URL opens up this destination. Because we are now dealing at a system level where third-party applications can launch screens in our app. You would have to declare this as part of your manifest file as well. For those of you who have done implicit deep linking already, you would know we have to declare intent filters that take us to declare which URLs or which paths are we able to handle. With the navigation component, that becomes very simple. Rather than declaring all the intent filters yourself, you can just include this attribute to your activity that contains the navigation graph, and then it will automatically at compile time generate the attributes for you based on which destinations have deep links within the given graph. The behavior of the backstack here is slightly different depending on, let's say, if they launch with a new screen, new task flag set. If the flag is set, they'll create a new task for your application, and then in this case, they will launch the navigation component will automatically launch every destination that leads up to the deep link. If the flag is not set, it will just add the destination, only the deep link destination on the task of the application that opened the deep link. So, for instance, Chrome opens the link, it just puts the destination on top of the Chrome's backstack. That's all about deep linking and how easy it is to handle deep links with the navigation graph and the navigation component. One last thing I want to talk about deep linking is when you have multiple paths that lead to a deep link destination. In this case, first, second, we have two paths, first, second, third, and first, third. The navigation component just takes the shortest path to the destination. So in this case, when the user follows a deep link, they would just see first and second in the backstack, not 1, 2, 3. Right. One last feature in the basics is the global actions. So suppose you have a settings screen, and users can reach this settings screen from anywhere in your application. You wouldn't want to have so many paths leading to the same screen from almost every screen in your application. In these scenarios, it would help to use global actions where you don't have a source of the action, as you can see in the blue arrow for the emoji prefs or the third screen here. This is how it's represented in the navigation panel. In these cases, you don't need to declare what is the source. We just say you can use the global action from anywhere to get to this destination. All right, that's about the basics. And there is more value prop to use the navigation component than just the basics I've discussed. We'll go through some of them now. The first one is the navigation UI class. So the navigation component comes with the navigation UI class. It contains some static methods that are useful for doing common things like when you navigate, it's not all about just navigation. it's also about updating UI to reflect what has happened. Um, for instance, things like app bars need to be updated with proper titles. Navigation drawer needs to be updated with the correct element selected. Same goes for the button navigation. So the navigation UI class has static methods to take care of all these things. Let's take a look at app bars on how it works for the app bars. So the navigation, anyway, the navigation component has, when you declare a destination, you usually define a label, as you see at the top. The label tells you what is the title of the page, and if you're using your own app bar, so you can get a link to the app bar, and then you can get the navigation graph, and then you can link up. You can use a static extension function called setup with Nav Controller, which will automatically link up the Nav Controller and the app bar. So when users navigate across the destinations, it will automatically show the right title. And yeah, that's for the. Not only does it change the title, it also does more things like, we talked about how you don't want to show the up arrow when you're in the home screen, whereas in any other screen you want to show the up arrow as an additional way for the users to navigate back. So this automatically takes care of this for you. This handy little tool method call will take care of whether or not to show the up icon, up arrow, or whether to show the hamburger icon when you're in home screen, or not show the up arrow altogether. It takes care of all these things for you by just calling this one method. It does similar. You have similar setup methods, static methods for other navigation components, but I just wanted to show you what it looks like for app bars. If you want to do more things when destinations change, you can. The navigation component has a destination change listener. So the navigation controller is the fundamental part of the navigation component. So whenever a destination changes, you can perform custom actions like sending telemetry and things like that. And one tip we learned from our experience is when users follow a deep link, it only triggers one event within the navigation, one destination changed event, irrespective of the length of the path. It won't trigger an event for every destination in the path. It will only trigger one event. That's that. And one important aspect of our apps is testing. For the navigation graph, let's say we had start activity and fragment transactions. These are system calls. So because we can't test them, we would probably have wrappers, like some wrapper class which says start activity delegate or start fragment delegate. And you use these delegate wrappers whenever you want to change a destination in your app. And then this is so that you can mock these delegates and see that classes are calling these delegates with appropriate arguments. That's one way we could test it. But with the navigation component, we won't be using these system calls directly anymore. Suppose you have an app where you have a home screen. When the user presses play button, they go to the game screen, whereas the home screen will pass which level to show the game screen. In this scenario, the things we want to test are that when the button is clicked, that the navigation happens, and the navigation happens to the right destination, and then the data passed is as expected. And also maybe the destination changes as expected, right? If you're using the navigation component, the things we wouldn't want to test are the actual fragment manager interactions, because it doesn't matter how the fragment manager interactions happen as long as we see the end output, right? And these interactions are heavily tested by the navigation component itself, so we wouldn't have to test it ourselves. So how do we do this? So we discussed how we use the Nav Controller to do all our navigation for us, right? So you can create a mock controller, and then you can inject it when your fragment is ready. So you can set the Nav Controller on the fragment when your fragment is launched, so that you can perform actions and verify that the Nav Controller had appropriate interactions or did not have the interactions you wouldn't expect it to have. If you want to test more complex scenarios like the destination changes and arguments and the backstack state, you could use the test nav host controller. This is a class that comes with the navigation components test library. So you can use this to test more advanced features, advanced aspects of your navigation. So the next one is Android has released the new dynamic modules. So these are modules which we can download, um, which we don't deliver to the user as part of the application package. These are modules that come at runtime when the user needs them on demand. So the navigation component also supports dynamic navigation, the dynamic modules using dynamic navigator. So the way it works is it downloads the destination when the user navigates to a dynamic destination, a destination which is not part of the current application. It will download it automatically, and then it will serve the dynamic feature module. It will serve the destination from the feature module. The changes you need to make are really minimal. So you don't have to, first things first is in the navigation host, you have to change the host to the dynamic nav host fragment. So this is a host which knows how to handle dynamic destinations. What I mean is, we'll see what I mean. So within the navigation graph, you should also declare in your some of your destinations will be part of a dynamic module, and the modules which are part of the dynamic module will also have a property called the module name. And once you make these two changes within your navigation graph and your navigation host fragment, um, and when the user tries to explore a dynamic module, it will automatically take care of downloading the module and showing this progress. This is the default progress it shows. And then when the download finishes, it will show up the destination as expected. Obviously, you can customize the UI if you want to show a different progress bar, or if you don't want to show a progress bar altogether, you can. But it can take care of downloading the dynamic module and showing the destination for you. A lot of features we've covered so far, and one feature I haven't talked about is custom destination types. So maybe not everyone is a fan of activities and fragments. And yes, you can have your own preferences. So you can create custom destinations and use them. Let's say you want to use your views for your destinations. You can. So all you have to do is define a custom destination. And so you extend the, sorry. Oh, well, no. So you define a custom destination by extending the nav destination. And then you implement the navigator, which knows how to navigate to the custom destination, because um, for fragments we use fragment transaction, whereas for activities we use start activity. So you have to define a custom destination navigator, which knows how to navigate your custom destination, and a host, which knows how to host this custom destination. And once you do those three things, you can use custom destinations in your graph this way. It's using like fragments or activities. There's a Medium post. Yeah. There's a Medium post which talks more about this in detail. So I encourage you to explore it if you want to use custom destinations. So far, so good. Everything. There's a lot of promised land in the navigation component, but how do we adopt it? Because not everyone is rewriting our application in the next 1 year or so, right? So we can adopt it incrementally, and we have. So I just want to give you a quick guidance on how we adopt it incrementally. The first things you want to do is slim down your activities. So if you have heavy activities, you want to slim it down. What I mean is you can move some of the UI logic to fragments so that the activity only owns the content areas of your application, and the activity only owns the navigation parts of your application, like the toolbar and the bottom nav, whereas most of the content is owned by the fragments. Once you do this, you will have activities and fragments. Once you have activities and fragments, you can create a navigation graph for each activity which has multiple fragments. So if an activity has multiple fragments within it, you can create a navigation graph for it. And once you do this, you can replace all your fragment transactions with the navigate call and dialogues with the navigate call as well. And that's the second step. And once you have enough activities and enough sub navigation graphs, you can create a route navigation graph where you can start adding your activities as a destination so that you'll have multiple subgraphs and then a route graph which links up all these things. This is the point where you can replace your start activity calls with the navigate calls. So pretty much all your navigation now happens with the navigate calls, which is a good point. You can do more optimizations like merging activities. So you can merge activities which have similar layouts so that you can merge their navigation graphs if you choose to. And at this point, you would have a good merge integration of the navigation component. All of these things can take months. It is possible to do it incrementally. You don't have to do it. It's not all or nothing. We have done this. And I just wanted to show as a last slide about introduction to our journey. So SwiftKey Android is as old as almost Android. So when Android announced third-party keyboard support in 2009, that's how that's when we started our Android application. So it's a very old code base, and we also have over 500 million downloads on Play Store. So we are dealing with a very big user base as well, and we have adopted this incrementally, and we are probably halfway through our adoption, and we've been using this for already months now, and we haven't seen any issues. If anything, our productivity has increased a lot. Obviously, we had the luck of including it as part of our app restructuring. So we only partially migrated it, and so far we simplified our deep linking handling a lot, and even the navigation logic is much easier to reason with, and it's easier to show it to the design team or the product leadership team because you have a nice graph. You can see how different screens go around. That's everything I wanted to talk about. I understand there's a lot of content. I'm speaking really fast, but thanks for joining me, and thanks for taking your time for the presentation. That's everything. Thank you.
Thank you, Praveen. We can move to the Q&A. So first, here are the results of the poll. Maybe you want to comment it somehow.
Oh, that's really good. I haven't expected so many people really implemented the navigation graph in the expected way. It's really good to see that people have put the effort to do the expected navigation that Android recommends. I would suggest if you adopt the navigation graph, you might be able to do this. You might be able to what do you say? Clean up some of your code because the navigation graph can take care of this for you. Yeah, that's about it.
Okay, let's go to questions.
Ooh, lots of them.
Lot of questions. So first question. Given that the navigation framework works using a common toolbar for all fragments, what's the best way to handle fragment-specific configuration, like fragment menu options, different icons, etc.?
You can define. So what we did, we ran into the same issue. What you can do is you can define. You can define a menu. What we did was for each fragment, we had an option called the menu. So each fragment has a menu of its own. Whenever you change we use the destination change listener. Whenever the destination change happens, we look for the menu option for this destination, and then we inflate the new menu so that every fragment can have its own destination, and at each time we're reflecting the menu of the fragment that is being put as the current destination.
Thanks. Next question is, to which module do you put the navigation XML in the multi-module project, including navigation between modules?
So you will have multiple navigation.xml files. So you would have a navigation graph within your module. Each module can be self-contained. So if you say you have a login module with authentication module which handles your authentication, you define a subgraph which talks all about your authentication, right? And then you will have a navigation graph just talking only about authentication. And then you'll have your main application which has a navigation graph of its own, and it will reference the navigation graph within your submodule. So yes, the answer is you will have a navigation graph within each module, and most likely the main module will reference the submodules, the graphs in the submodules.
What if you want to navigate from one module to another? How would you do it?
Um, I haven't tried how we navigate from one module to another, but my yes is you can use the global actions. That's off the top of my head, but this is something I haven't tried. So I don't have a straight answer to that. So
Okay. Next question is how to solve special case of navigation animations, right to left layouts, for example, Arabic languages, require opposite direction of the animation.
oh, that's interesting. I haven't thought about this one. This comes as a surprise question to me. But this is something I'll have a look at. This is a very interesting question. My answer is I don't know the answer to this, but I haven't even thought about this one. I say great question. I'll have a think about it. I'll be sure. I'll remember to respond once I have an answer on the Twitter.
Thanks.
Thank you. Yeah.
Next question is I have worked with nav component quite extensively, but didn't find a smooth way of using this component with activities. I saw only fragment navigation in your examples. How do you approach this?
So for SwiftKey, we haven't migrated everything. We have lots of activities. So what I noticed was the navigation component doesn't actually handle activities very well. You're right. So we used it as sub navigation graphs. So we use it does do the activity calls. Let's say we define activities as our destinations, and when you click a button, you take the action. This action would point to an activity. In this case, the navigation graph already knows that the destination is an activity, so it will take care of calling using the start activity call and passing all the arguments. But that's about it. Once you go to the next activity, the life cycle of this navigation graph is finished. Like the life of this navigation graph is finished, and if you have in the life of the new navigation graph or the nav controller within the activity kicks in. And once you press the back button on the navigation on the destination activity, you will kick back in the previous activity. So it's not really smooth. But from our experience, we could just declare activities as destinations and it would automatically take care of launching these activities. One issue we found is with deep links. We had to be careful how we use deep links when you have activities and fragment mixes in your deep link. Um, in these cases, we were able to avoid crashes by just navigating straight to the deep link rather than following intermediate paths in the deep link. Because the navigation graph doesn't actually create everything in the deep link up front. It creates them as user uses the back button to navigate there, which is what we would expect to be efficient. Yeah.
Thank you. And last question is it possible to skip a screen in the backstack when you're navigating back? For example, when I'm going ABC, then go back, I would like to go back to E, skipping the B.
Yes. I haven't fiddled with now. I personally haven't fiddled with changing the backstack, but I've gone through the documentation extensively for the presentation, and when I was using it, it is possible to change the backstack. There is docs on the Google navigation component. Um, docs of Android navigation component shows you how to modify the backstack if you want to. But I haven't personally done it, but it's definitely possible to change the backstack to yes, yes. The example here is definitely possible.
Thank you. I will now enable a poll for rating of this talk. So please rate so Praveen can have some feedback. And now Praveen is going to the 3D world. He will be at the speaker's corner. You can find him there, ask him maybe more questions, almost in person. The speaker's corner is next to registration, really close where you appear in the 3D world. And when you are in 3D world, you can visit also our partner booth. There are some surprises for you, both virtual and real. And we will meet again at this stage for the next talk at 15:10. That's 3:10 p.m. Prague time. That's GMT +2. So Praveen, thanks a lot for your talk, and see you in the 3D
Thank you.
world.
Thank you. See you soon.